but as an organization, you might be interested only in a subset of some controls for which you
Yeah.
could model and be ready.
Yeah.
Okay.
Yeah. So as I say, I'll stop the share there. We can go back to chatting.
Sure. And how do you correlate these models to the real world, where I saw you actually end up creating some graph databases of these outputs and then linking them to other notations like OSCAL, for instance, that
Okay.
I did
All
hear
right.
that you did talk about that. So how does Archimate tie up to OSCAL? That's the next logical progression.
Okay, you want a journey from okay. So
yeah.
Okay, there are two questions inherited in that. So I might choose to tackle them both.
Yeah, one after the other in your preference. Yeah, whichever
the first
makes sense.
question is the move from working within the Archimate tools to a graph database.
Yeah,
right?
I think that is.
I'll illustrate that by just picking up from the previous slide in a moment.
Sure.
And then the second question is, okay, moving away from an application of this technique from risk assessment to compliance, which is the area where OSCAL, and for anyone not familiar, OSCAL is a new NIST standard for the automation of compliance checking. Right, so we'll go to that story. If I just I'll just share back to where we were. Now, the Archimate is there, right? So this is the qualitative example from the Open Fair Institute, and you can see here that the graphical capabilities of Archimate are just about okay for attaching these labels to Archimate elements and presenting a flow, if you like, that shows how changes at the bottom by adding controls implement the controls at the top, right? Now, the Open Fair example also includes a pure quantitative assessment of the same scenario, right? So if we look at the quantitative assessment, that's this one, and I'll try and make it larger in a second. I'm clicking some screens down. Oh no, wrong click. That one. Okay.
Yeah.
Now what we've done is replace those colored boxes with the quantitative probability distributions, right? So we're saying that what Open Fair in its quantitative mode wants is not like a single guess high, medium, or low of the value at any one point. It wants a distribution range, a probability spread, okay? It wants the mode, the most common value you think that element is, and it wants you to give a 90% range. So from 5% to 95%. Yeah. So for each of those elements, instead of having a colored box and high, medium, low, we've got this this triple. The 5%, the mode, and the 95% spread, if you like, of each of these potential responses. Now, when these combine...
No, sorry, what is the 5 and the 95 one? The 5 is the least occurrence, and...
Open Fair says, don't give me a single high, medium, low estimate of what you think this value is worth. Okay. Give me a 90% spread. Okay. It can be as wide as you like, but the true value should be in that range.
When it's least occurable, what could be the potential value, and when it occurs the most, what do you think is that? Is that the way to interpret it?
Yeah, it gives you an expression of how certain or confident you are in each of the estimates you give. So it has to estimate, say, what you think the most common or the most likely value of that detail is, but it allows you to express a range of uncertainty.
Okay.
Right, so you end up with these three values. The difference between the 5% and 95% is your 90% confidence interval. And somewhere in that range, there's your most likely value. And it might be central, it might be skewed to the left, it might be skewed to the right.
Okay.
But you have to think of these things as a kind of distribution curve.
Okay. But how do
Based
you
on those three
realistically, sorry, how do you realistically arrive at that? Because it could be anywhere from 0 to, why only 95? It could be 96 or 97, 98. How do you peg it at 95? What do you think should be enough?
It's just to guide the people that are estimating.
Oh, okay.
It says, try and give me a range in which you're 90% confident that the true value lies within that range. And with that technique, you can estimate anything from, the length of the coastline of Norway to the birth date of Genghis Khan. It really doesn't matter. You use it. If you know it, you can give a very tight range. If you don't know, you give a very wide range. But they just ask you to be
but in this particular scenario, yes, in this particular scenario of employee information misuse, okay. So you're saying the chances that he might misuse is 90%, basically.
Yeah, it's like what's the chances of someone in the cleaning crew misusing that information? And you say, well, basically, cleaning crew most of the time are very honest people. So maybe it's 1 in 100, but it could range between 1 in 75 and 1 in 250. You might say that, yeah.
Okay, yeah.
Now the thing is that when you try and combine these things in these quantitative estimates in the quantitative mode, you end up with, well, it's a bit like multiplying probability distributions. You can't express it in a nice number in Archimate. Its graphic capability is too limited. What you end up with are what you want are kind of like diagrams like this that the open fair public tool gives you, right? So here you've got, the loss magnitude. How likely is it? Okay, this one looks like it's, 4%, it could be between 350 and 400, 6% between 400 and 450, 10% above 450,000 a year, right? This is the kind of, what's the chances of exceeding losses of more than 600? Well, maybe about 50%.
What the x-axis is the loss in terms of monetary loss?
Yeah, what's your expected loss magnitude per year? This is a diagram calculated out of kind of like Monte Carlo simulation based on those statistical properties. All I'm saying is here that the graphic capabilities within your typical Archimate tool don't allow you to do this.
Yeah.
Right? It allows you to attach simple labels in the qualitative model. Yeah, fine, no problem. But if you want to do this properly, you need to take that data, that machine readable model that you've created in Archimate, and just transfer it to a general purpose database. And then on top of that database, you can build applications that do anything you like.
Okay. Sorry, Stephen, on this diagram, when you say 350, is it $350,000 or euros or?
Okay, for that I have to go back to the diagram. Let's look at the top level diagram, risk. Right?
Okay.
Here, okay, it doesn't say. When you set up this Archimate tool, you say what your units are. Could be thousands of dollars. Let's say it's thousands of dollars because it's the standard example. Okay.
Okay, makes sense.
But basically, we're saying here that blue is the current situation, orange is the situation with the control added. So you basically do Monte Carlo simulations with and without the control, and you try and see what the difference is in terms of probability of risk, of loss expectancy, of number of events occurring in a year. And you can see in this example, the control isn't making a great deal of difference, if any at all.
Yeah, but the first diagram is proposed one is reduce the spread of the risk than what it is, and the chances of it exceeding are.
So this is loss events, so not counting the cost impact of each event. You see, it's not really changing. The two are going step by step. So whatever this control is, it doesn't change the number of loss events per year, and it doesn't seem to impact much the average loss per event, which is the loss magnitude calculation, the first one that we had. Okay, but that's just, I was just trying to, demonstrate here that, why we need to take this information out of an Archimate modeling tool, which is primarily there for documentation and communication, and put it into a proper database so that we can do more sophisticated analysis and graphics with it. Okay.
Yeah.
That was the first part of you. That was the first part of your question.
Correct.
The second part. How
does Archimate tie to OSCAL?
Okay. So let me share something back from the slide then, because here we're talking about we're entering the world now of multi-regulatory compliance. Okay.
Yeah.
Now, probably a bigger concern for most of the organizations, certainly that I work with, which is mainly clients in a highly regulated environment, is not the calculation of individual risks, but showing the auditor that they're compliant with regulations, right? And these compliance tests come from regulators, come from government, come from your key clients that want to make sure they want a statement about the security of their extended organization. So basically, with partners, maybe for example, the financial industry, SWIFT now require all their clients to have a statement about their security posture around their SWIFT infrastructure. So what organizations are increasingly seeing are more compliance drivers on them, that those drivers not only are more frequent, that every year the standards are increasing, and that their compliance statements are being held to ever greater scrutiny, right? Yeah. And so the amount of time and effort that they're devoting into proving that they're compliant with X different schemes is just growing all the time, and they're struggling to work out a way to handle it. And that's because they're basically dealing with a multi-dimensional problem. They've got control objectives, control requirements, control measures, statements of what's in scope, out of scope, what are the risk factors, the whole risk is there. It's an n-dimensional problem. And the way, and to be honest, the only tools the teams that are trying to keep on top of this compliance demand, the only tools they have are spreadsheets. Okay. They're trying to model a multi-dimensional problem with a three-dimensional,
two or three-dimensional spreadsheet.
Yeah, and of course it's causing a lot of stresses and burnouts and arguments, and nobody looks forward to this job. And some of these audit requirements are statements that have to be made every year. Okay, now imagine now though that this n-dimensional problem is something that Archimate does naturally. That this is what we're talking about when we say we've got multiple views on a single underlying model. You can give each stakeholder that particular view, and the model is just a mesh. It's interconnected network. It's got no regular structure. So what we can try and imagine, if you like, is a different approach to automated compliance, where on the left here we have the compliance framework built. It's published as a standard. It's got several domains. Within each domain there are control objectives. Those control objectives are realized by a number of requirements, usually ANDed together, and they're evaluated against certain evaluation criteria. That's what comes in the standard. What we have in our target model, the thing that we have in our enterprise architecture repository, are a number of core elements, to which those control objectives are applicable. We've also got a number of core elements, thanks to our security overlay, that are actually acting as controls. And those controls are either structurally or behaviorally have dependencies on the core elements, the things that the control objectives apply to. Okay, so that what you've got by modeling your control framework in the same system as your enterprise architecture is this set of associations where you have this control objective, you know what it applies to, you know the requirements that you need to complete to be able to deliver that control objective. You know where those control requirements are actually implemented by real world mechanisms, be they processes, responsibilities, services, application logic in your real model. And provided the thing to which that control objective applies is using that control mechanism, you have this closed loop. You can see, is it with my cursor moving around?
What would be an example of the top core element in the enterprise architecture?
What would be an example of a top core element? Okay, well, let's suppose
something abstracted, right? If it's a business process.
Let's say something like the control objective there. It comes from the GDPR about privacy, and it says that your the personal data has to be held in secured databases, and there needs to be access control, and you have to have consent.
It has to be depersonalized and probably obfuscated.
Yeah. So the control objective applies to the business informational personal data. The control requirement for consent would be realized by the publication of a privacy policy on the website.
Okay.
Right?
Yeah.
So here you've got your privacy policy published on your website or on your enrollment screen, provided that that privacy statement is covered or is associated with that piece of data, and what you say in that privacy policy isn't in conflict with the way that piece of information is going to be used. You kind of have that closed loop that you can tell from your model.
Okay.
And already you can perhaps see that is a network path. In a graph database terms, looking for a closed loop, a closed path, is something that those kind of graph databases are kind of designed to do, right? You struggle to do that with a SQL database, a relational database, because the number of joins would kill you, right? But in a graph database, that's quite natural. Now, having found that control mechanism exists, is it producing an audit record? Is there evidence, which is the second part of compliance? And then does that evidence meet the evaluation criteria? Does it come up to the right standard of what you need to tick that control objective off? Right?
Oh, okay.
Now that's more of a subjective thing. That's kind of like harder to do in a mechanized model or an automated model, if you like. But certainly you can say that if that closed loop here doesn't exist, you've very probably got a compliance problem, because either your model isn't up to date, okay, you can fix it easily, but maybe that's a control objective where the requirements aren't complete. These are missing requirements.
Okay.
Requirements that don't have an implementation. Okay. So okay, now the next slide is actually just highlighting the fact that you've got that loop there.
Yeah.
So basically what we need to do now then is to not just model our target system, we need to model our control frameworks. And again, through this security overlay that we've been developing, this is how a control framework looks in Archimate. I mean, you might recognize this one is
the
NIST 853. It's made up of what, 20 domains?
Yeah.
We can go into a domain and see what the control objectives are. We can pick on any particular control objective, and we can see the objective and the underlying requirements that ANDed together will realize that control objective.
Okay.
So we can start to see here that by modeling the framework and the target system in the same model, we can start to make rational analysis with automation on how well our control frameworks are being met. Now, the final side comes to OSCAL.
Yeah, so sorry, before that, Steve, one more point is that conforms to the ISO 27000 control objectives or NIST 853 standard. So which one does
this particular example here is the NIST 853, and I use this one more, well, certainly in presentations more than the ISO one, because obviously the ISO one has got strong IPR rights.
Oh, okay. Okay.
Right. So, but essentially, it doesn't matter whether we're doing like the NIST 853
Yeah,
here,
it
or
could be,
cybersecurity control set, or CSA, the cloud framework.
Okay.
They all follow a similar structure.
Okay. Okay. Makes sense.
Yeah. And if you'd like, I can show you the graph demo of that if we still have time at the end.
Yeah. I think we have time.
Well, you touched on OSCAL. OSCAL is the Open Security Control Assessment Language, and this is NIST, acknowledging that the compliance burden on organizations is just becoming overwhelming, and they've taken steps to automate it by producing schema for what they see as a typical compliance pipeline. So what you have here on the left is the control frameworks. Here they've got the NIST 853, COBIT, ISO, and what they're saying here is that if we publish this as an XML schema, not only can we render that into kind of like human-oriented form, like a Word document or a PDF, where you can read it, understand it, well, I'd say review it is a standard, but basically humans can understand what's required of them. But because it's become from an XML source, there's also a machine processable part of it where you can basically chain the basic control framework, tailor it to a subset that apply to a particular architectural component or building block or an architectural pattern. You can then build a system security plan for your own architecture by taking the baseline controls for every component in that architecture and aggregating them together. That gives you a unique system security plan for every component in your target environment. Then you can execute that plan to demonstrate where you've got controls and evidence. And then finally, you create a report that shows the state of your compliance. And in theory, because this is automated, you can do this on a continual basis. All right. Now, when I saw this, and I've been starting from OSCAL, I was taken by the fact that these arrows in the top here, from the XML world to the human-oriented world, were all pointing upwards. And I could say, yes, it makes sense to publish the control frameworks in XML and render them as PDF or as Word. But it didn't make sense to me that something like the documentation of your own systems architecture, I just couldn't conceive of people documenting that in raw XML. It's too big, it's too complex. How the hell do you review it? How do you get it signed off? How do you maintain it? Raw XML is not the medium to work with, okay? So what I was thinking is that what we have here when we're documenting our security in our as an overlay to our enterprise architecture using Archimate, that we could actually create this Archimate model that contains everything we need to know about our system of interest, our target system, and using XML conversion, we can reverse that arrow, or we can do round trips. We can create in Archimate, we can have the thing reviewed, we can have it approved, it becomes maintainable, and when we've got a stable copy, we can use XML transformation to generate the necessary OSCAL artifacts and then run them in the knowledge graph or in any other OSCAL aware or OSCAL capable processor, which increasingly, enterprise risk management tools will have. I mean,
Okay. Yeah.
I think version 1 was only December last year.
Okay.
Yeah.
So, yeah, I get. I think a bit of the things I need to catch up on the side, but yeah, I get the overall picture that you're trying to say, that you can actually pretty much automate the entire set of controls
Yeah.
and create an Archimate out of it in OSCAL. So how does I think the last part of your thing was connecting it to the knowledge graph.
Okay, let's have a go at knowledge graph then. So
Yeah.
I could show you an example, one based on risk or one based on compliance. Which would you like?
Sorry, what are the options? One is risk and compliance.
The options are, one would be looking at a very simple one of the demos I've got lined up for this is a very simple example model, a small model that you can easily grasp, which shows a number of like simple queries you can do to try and understand a risk-based view of a system, or another model which is looking at this, that's multi-regulatory compliance, looking how one control framework maps to another so that you can easily navigate across multiple frameworks.
Yeah,
right?
I think we can quickly go through both of them, perhaps.
All right.
I think, yeah. So
All
except
right.
that it be perhaps one long talk. So
Okay.
but it's going to add a lot of value to
Okay,
everybody
so
else.
let me just skip to another point in this presentation then, when I will introduce, let's start here, see how this goes. Right, so what we're going to do is basically describe our security enhanced view of our enterprise architecture in an Archimate tool with the security overlay. This is Archimate Security Enhanced. And we're going to take a XML transform here, mix it in with data from the real world. So perhaps from your CMDB, perhaps from the CVE database on the web, perhaps from an Excel sheet from, I don't know, like a pen testing or a static analysis test report. And we're going to create it into this pure database form, right, in which we are no longer constrained by the graphical capabilities or the analysis capabilities of our Archimate environment, where the security elements that were kind of like squeezed into Archimate on the left become first-class graph citizens on the right. We end up with a pure data, just a database that we can use for general purpose applications. That's what's going to happen. So we're going from, in my case, Archi to Neo4j and mixing in a bit of data.
So when you say Archimate Security Edition, is it basically the notations and the meaning that you've created to transform?
Yeah, this Archimate SE is just a name I use to differentiate.
Correct. Your own tweak on the security. Correct. Your customization for security.
Yeah, it's got the security overlay applied to it. Okay.
Yeah.
So this would be the typical model that I would want to show. It's only maybe 30 elements, but it's complicated enough to be interesting, but not too large that it's not understandable or not absorbable, right? So
SBA is like security business attribute. SBA.
SBA is the SABSA business attributes.
Oh, SABSA. Okay.
So remember, we had to introduce some security concepts. If we want to model SABSA in Archimate, you have to start with attributes. Correct. Occurring in Archimate, we have to find a way of representing them. So for me, it's a stereotype of the Archimate principle, and I give it that stereotype notation, SBA. You might notice a few other stereotypes in here. So I make a specific stereotype of a client or a data subject out of an actor. Yeah, because obviously that triggers all the privacy concerns. If you say that a specific type of actor is also a data subject, then you use that to trigger the fact that.
What do you mean when you say data subject?
Okay, a data subject it can be like a customer typically, or it can be an employee or a citizen that is
Okay.
providing you with personal data.
Okay, okay. This is the GDPR slide you said, okay.
It could be, so it could be, it's related to GDPR, and that's a big thing
Oh,
over in
okay,
the.
okay, okay, perfect. Yeah, yeah, please go ahead.
So
Please go ahead.
you need to differentiate between someone that's providing personal data and somebody that's just maybe like an administrative operator that's doing a
Yeah, yeah.
role, but they're not providing personal information.
Yes,
Okay.
yes.
So this is a client. They're calling a customer helpline. This is not a web application. This is maybe like a telephone call, or it's email. They've got some kind of service level agreement. That service is backed by a service desk function that is being staffed by a service desk operator, by someone in the organization, and they are reading business.
Should the arrow be the other way around, Steve? Should the service
Which
desk?
one? This one. The
Yeah,
reads.
the reads.
No,
The
in
arrowhead. Okay.
Archimate, there's an underlying action that goes left to right. So the service desk accesses the business object, but the
Yeah.
arrowhead indicates whether it's a read or a write or a read write or an unspecified type of access.
No, no. What I meant was the direction of the arrow. Should it the endpoint of the arrow, should that be on the business object, meaning that service desk is the one who is reading the business object?
No, because the
Business object is being read by the
service desk, yeah.
by the service desk.
Yes, the service desk is reading business information.
Okay.
So they're looking things up in a database.
Okay.
That's basically
Okay.
what it's saying.
Oh, okay. Okay.
Yeah. Now that service desk is using an application to do that. So now we're in the Archimate logical layer, and we're saying that service desk business function is using an application service that provides functions provided by a component that has an interface. Basically, it can trigger a failure event, but basically this is reading the logical the representation of that business information, this realized relationship. So the application function is reading data, whereas the service desk is accessing information. But it's just split into the different architectural layers.
Correct.
And then on the lower layer, you see how that application is deployed on the technical infrastructure.
Yeah.
So we've got a web server and we've got a database server connected by a local network.
Yeah,
right?
yeah. And the artifacts are a JSP file and a data record.
Now, looking at the SABSA the part of it, we know we have a SABSA business attribute where the organization wants to be compliant, right? The data protection officer is obviously has that concern with respect to the GDPR compliance. So if we can achieve GDPR compliance, that will contribute strongly to our overall compliance position.
Yeah.
Right.
Yeah, yeah.
What do we need for GDPR compliance? Well, among other things, we need the informed consent and we need the controlled access. Yeah, and the other one's behind my video screen. There's another one there as well.
Okay.
But basically, that's the basic scenario. Okay.
Yeah.
Now, what I'm going to show you in the graph demonstration of this is how that when we populate these elements with properties from the overlay, we can do very simple scripts that can tell us where is our personal identifiable information being hosted, our PII, our privacy sensitive information, which are our critical applications. Now, a critical application audit is typically done by a survey that comes around every year to application owners, where they have to fill in how critical is your application, high, medium, or low.
Yeah.
And to be honest, they don't know, because in a service-oriented architecture, they're not always aware of which services are connecting to their application. It's probably different from the day that that application was first deployed. It could change every month, right? But yet, there's a better way to do it. Have all our SABSA attributes been implemented? How are we from an enterprise security architecture point of view? Have we got everything covered that we care about? Are all security events being handled? Well, you can see here automatic from the diagram that it's not obvious that that event is being handled, but we can use the machine analysis of the model to just prove it. There's another interesting example that's about a protection profile. Now, a protection profile is, a kind of property that arises from the NIST cybersecurity for critical infrastructure framework, where they say for every control objective that you have, you want to be able to deter, prevent, detect, respond, and recover from an incident. So you might want a defense in depth approach to this particular goal. That means you've got multi-layered security applied. Okay. So how does that work in practice? We talked before about how a goal can be realized by combining multiple requirements. So here we said we've got this goal of preventing unauthorized modification of data, and arbitrarily we've set everything to moderate. Okay, we want a very flat, evenly spread protection profile. How do we deal with the deterrent part of that requirement? Well, we have an acceptable use policy that says, what is the appropriate use of sensitive data, and that policy doesn't prevent things happening, it doesn't detect or recover, but it provides a moderate deterrent. In other words, it's stated that you shouldn't misuse data, and there's some sort of sanction if you do. Okay. How do you deal with the accidental or malicious corruption? Well, you can do that by applying a checksum, or even stronger, a digital signature to your data. And those type of controls, they don't, well, okay, a moderate deterrent if people are aware that that control exists, but it's actually a strong, a checksum can be a detection mechanism. It doesn't prevent the tampering, but at least you can see that it.
So right? Just a question here. Why are we saying? Sorry, just interruption. Why are we saying this respond and recover are not available? And so because we don't have a defense for that. I mean, there's no way for us to respond to that.
Yeah, because usually the if you've tampered with data and the checksum is broken, the checksum won't tell you how to recover the original data.
Okay.
Yeah, it just tells you that it's not in its authentic state.
Okay.
But it doesn't help you recover. You better have a proper copy somewhere if you want to get back to the original data.
Oh, okay. But on the face of it, that by itself, you cannot do anything. Unless you have a parallel copy of it mirrored somewhere.
Right. It won't help you recover. Yeah.
Okay.
So that's the idea of a protection profile. So what I'm going to do now is show you what. Okay, I'll just quickly remind you of what the model looks like. Just bear that in mind while I load up the graph database.
Yeah.
Because over here, I will open up Neo4j. Right, I'm going to have to move the camera out of the way a little bit. So what we're going to do is just look. Here is my model. I'm going to just refresh the map and open the screen. Now, that model that you've just seen in Archimate is now been just exported out of the Archimate tool and converted into the graph database format. Okay.
Yeah.
Now, you might remember that the diagram I just showed you had this domain, that separated the internal organization from the client and the external world. That's connected to everything, well, most of the model. So I'm just going to release that one from the diagram just to make it expand a little bit, right?
Okay.
And now I'm going to just reorient it so that the purple kind of motivational stuff is on the top.
Okay.
And how do I untangle this? Or can I? find a way to. That's better. That's kind of looking a bit better. Yeah, that's it. So now it's looking at it's the same stuff, but in a slightly it's arranged in the right way. So at the top, then we have our client. You might recognize. Here's the GDPR, sort of the purple stuff. Here's our service desk. Here's the applications, functions, and services. Here is the data object, realizing the business object. So you can see here that the taxonomy of the element names and the relationships, it's all equivalent to what we saw in Archimate.
Okay.
Right?
Okay.
It's the same model.
Okay.
The only thing is, okay, we don't get the symbols, and it's
The
only really
properties of that. Are we able to get the properties of these elements?
Oh.
No. Okay.
So if I go to our business object here, can you see at the bottom? We've got the confidentiality rating. We've got
Okay. Okay.
Yeah.
Yeah.
The overlay properties are all built in there.
Okay.
Now, looking at a model like this it's only really possible because the model is small. Most real world graph databases you look at are like, the Death Star out of Star Trek. They're just not meant to be taken in visually. You can think
nebulous
of it as a hairball.
and correct. It's like a Milky Way. It goes on and on and on.
Right. So what I'm going to do is just collapse that out of the way for a moment, and then we will look at some queries. Right. So what did I promise? Where is our GDPR data being collected? Well, so what we have here for analyzing that model is a series of numerous but really simple scripts. I mean, if you imagine doing this with JavaScript in Archimate model, some of these would be serious amounts of code.
Yeah.
But in a graph database, we can say something simple like, find me, this is where is my personal information, okay? So it asks you to walk the graph and find me nodes that are assigned to data. So, data that's stored on a particular node in the infrastructure, where that data realizes through two realizations up to the business layer, a piece of business information, BI, right? Where that business information, personally identifiable information field is set to personal or sensitive personal. These are the ones that we're really worried about. And then turn me the name of the node. And if we run that, sure enough, our client database server is containing information that comes from the business object that's rated personal. Okay. Not very remarkable. In a sense, it's a very simple query, but we can do far more than that. Okay.
Absolutely. Yeah.
We can find. Well, let's do some stuff with our SABSA attributes. We can say, are our SABSA attributes properly met? Right. So find me some business information that's associated with a SABSA. With a SABSA attribute where the confidentiality is confidential or the confidentiality is secret, and the SABSA attribute has got a confidential label. There isn't one. That test happens to pass. Let me find one that will fail. They're more interesting. Are our requirements not met? Right? Requirements not realized. You remember that meta model where I showed control objectives implemented by requirements? Those requirements have got to be realized by something in your real world architecture.
Yes.
So this is simply saying, find me all the requirements in our model where the requirement is not realized to anything. There's nothing in our core elements that's realizing an implementation of that control requirement. And okay, we had maybe 2 or 3 requirements in our model, but one of them, the controlled access, wasn't attached to anything. Or, okay, not in the diagram, but not in the underlying model either.
Okay.
So then we can say, well, given that control requirements not been realized, which of our SABSA business attributes are being affected? So now our match statement becomes slightly longer. We say, find me requirements that realize goals where the goals implements the SABSA attribute where the requirement's not met. Okay, and that now tells us that the fact that we've got no realization of the controlled access requirement is impacting our goal of GDPR compliance, which is affecting our overall organizational compliance stance. Right?
Yeah.
There's another one in this series that says then tell me which stakeholders are impacted, and obviously it comes back to the data protection officer.
Okay.
Right. So now let's do something like an audit. Remember we talked about the critical applications audit?
Yeah.
As an alternative to just going around asking the application owners how critical is your application, we take a different approach. We say, find me all the application components that are assigned to functions, application functions, where that application function is realizing a service, and that service is serving BF, a business function, where the business function criticality is greater than the one documented for the application. Right? The business owner, the application owner says this application is low criticality, but it's supporting a business function that is rated at a higher level of criticality. And then we return the result. Sure enough, our application component has been rated as low criticality by its owner, but it's supporting a service desk that is rated as medium. Right? Now, it doesn't sound like rocket science on a small model of 30 elements, but a typical enterprise architecture model has got maybe 10,000 elements. Right? But it's a simple 3-4 line query where you can run this critical application audit instead of once a year and being a real pain. You can run it every night if you want. Okay. Every time new applications are deployed, every time new services or new services are onboarded using that application, you can check. You can check whether your criticality ratings are still correct.
Oh, okay.
As one final example, because I think it's one of
you said about the multi-regulatory stuff when it's
different model. Yeah. I'll show you that one in a couple of seconds, but you're having introduced that control profiling model. I'm going to run another one that just basically says, has our our protection profile been achieved? In other words, for all the goals or objectives in our model, do we have the right level of deterrence, prevention, detection, response and recovery? Okay. Again, what's this? A 10-line query. Yeah, maybe even be shortened. But here we go. Our GDPR compliance check has not been achieved. Why hasn't it been achieved? Well, we can check here is, have we failed to fulfill the identification part of the profile?
Okay.
No. Required to achieve level 2. Okay. It's not identification. Is it deterrence? Let me see if there's that one. So deterrence, required 1, achieved 2.
Okay.
What about prevention? Let's try that one. Protection. Protect is required to achieve 2. Prevention. Okay, let's do detect. Okay. Detection is one of the criteria that are failing. So if we run the detection profile, we were meant to achieve 2, but the controls we've implemented have only reached level 1. right?
So
So
what is that? What does the 2 and the 1 mean? Detect.
okay,
Which
so
one?
if I flick back to the graph here, I'll show you. Remember this one?
Yeah. Yeah.
Right. So basically 1 and 2 are enumerations of weak, strong, moderate, not applicable.
Okay.
Right. So it's just basically doing a numeric comparison rather than a text based on labels.
Okay. Okay.
Okay. So what did we say? Like our detect or response, we wanted moderate level 3 and we only achieved level 2 low, right? By not having a proper okay, what would detection be? Logging, recovery would be backup. Yeah.
So
So
it would be
that's a yeah.
Data would be 1 if it is slightly stronger, and 2 if it is very strong.
I
Something
would
like that.
say not a 0 is would be not applicable, not there at all. 1 might be weak, 2 might be moderate, 3 might be strong, 4 might be
Okay.
very
Okay. 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 Got it. Okay.
yeah.
Yeah.
So you say it's but by just being disciplined and applying these properties to all the elements in your model, there just seems to be no end to the type of very simple queries you can do, looking
Okay.
for completeness of your model, looking for the fact that you might look for certain risks. Actually, there is another one that I might show, but I haven't prepared it, but I've got in risk here.
Yeah, you said the multi-regulatory environment, right, where it can be a nightmare.
Yeah, that's right. But if we look at the risk. All right. The multi-regulatory is a different model. So I'm going to close this browser down.
Okay.
And we'll switch over to the right. So that was the simple model that I think you saw from the COSAC demonstration. If we go to control frameworks, let me stop this model. It will only allow me 1 at a time. So that's the Archimate demo. Let's do this one. I will run multi-regulatory frameworks. Okay. Now, while this is loading, I'll just look at a bit of background. So you've seen the model of NIST, right?
Correct. The GDPR compliance I saw.
Yeah.
So
The one of the models that I want to show you, like a cross-ref. I mean, NIST is very general purpose. If we were dealing with cloud applications, the framework that we would probably be more interested in is the cloud control matrix from the Cloud Security Alliance. You see this one here?
Okay. Okay.
Yeah. Now, what you see from this one is that, as well as the the control code and the description, you get a nice breakdown here of whether that control applies to the physical world, the network, the compute power, the storage, the application, or the data. Right? They're all categorized quite precisely. You also know whether that control is applicable in a SaaS, a PaaS, or an IaaS scenario, and if so, whether it's primarily the responsibility of the service provider or the service consumer, or it's a joint control, it's a hybrid.
The shared responsibility model.
Shared responsibility.
Correct.
So it's a very good standard from that, because there are lots of properties there that you can use to discriminate and select the appropriate controls.
Okay.
It's also a very nice standard because it cross-references to dozens of international and national standards, whether they're American, Canadian, German, Australian, international. So you can see that here we've got some sort of mappings to various editions of NIST, and the trust service criteria from the American Institute of Chartered Accountants, ACPA, yeah, professional accountants.
Yeah.
So so here's a standard with the controls and the requirements. Lots of selection criteria and lots of cross-reference mappings.
Yeah, so this is like a huge mishmash of a lot of.
Yeah. It also comes with like a questionnaire to how to evaluate, and it tells you whether for NIST, the mappings that are proposed between CSA and NIST are a full mapping, or whether there's a gap, or in some cases there's no equivalent in NIST at all.
Okay. This reminds me of AWS, Amazon Web Services, being compliant with 239 cloud security standards just for compliance.
Really rich in terms of information. It is all I wanted to demonstrate here. So I'm going to close those two down. And we'll go to our graph model. All right. So again, stand by for this one, because this is not like a dummy model, specially prepared for a conference demonstration. This is a real life working model. So what we have in multi-regulatory frameworks is here. Oh, let me first load the model first. Refresh the map. There we go. What? I'm sorry, that doesn't look right. Ah, I know why. I only loaded 50 elements. Let's put 5,000 in. Right, so now we get a sense of the power of graphs, right? And why doing it with an Excel spreadsheet is
I get the point.
Right. So you remember I said in most real world applications we're looking at a hairball, a rat's nest, a Death Star. This is actually a model that contains 4 standards. Can you see here? 4 standards.
Oh, okay.
And those are the NIST 853. The NIST controls for critical infrastructure, and the Cloud Security Alliance control framework and the questionnaire. There's NIST in the middle of the Death Star. It's a big one. Just let it zoom out a minute. I mean, again, no human will try and work with a graph model on this scale. It's just I wanted to give you an impression of the size and complexity of just 4 standards cross-referenced against each other. Having said that, graph databases are meant to scale to terabytes, and these models are, like gnats bytes in terms of what graph databases are capable of in terms of volumes of data or analytical performance. I mean, what we're doing here is not real time, and in graph terms, they're not large models. So we're we're not even scratching the surface of the performance part of this. That twin pair there, that's the Cloud Security Alliance and the questionnaire, tightly coupled, right? The cyber framework's probably floating up somewhere in the north. Okay.
Yeah.
But
Stephen, one more point. I think the Zoom is set for 2 hours, so we perhaps might have another 5 minutes, because we might get locked in. The Zoom can get time out. Well, because I set the initial meeting for 2 hours, so we might run into a risk of getting chopped in between. So we might have another 5 or 10 minutes.
I try and wrap up in 5 minutes. The quickest way for me to do that is probably we've seen enough of this monster. It'll run faster if I turn the graphic rendering off. Okay. So here we go, and then go back here. Now, let's have a look. Let's do some queries. Multi-regulatory framework queries. Start off with a really simple one so that we can see what we're doing. Okay. This is a query that just says, find me the control objectives in the cloud framework and tell me where they map to a control objective in the NIST framework, and then return me the names. Now,
So this, unless we kind of design these the schemas in this way, this is not going to render anything, right? So we need to be able to intelligently input and create this graph schemas in such a way that
yeah. I mean, in effect, we'll be sharing these public models through the SABSA Institute when probably over the summer. It's one of the things our working group have been working on the last year.
Yeah.
And because it's public information, there's no harm in sharing it. And I don't see why, say, like numerous organizations around the world should be wasting time modeling the same stuff. So this is all open source, and we plan to share our models just as the underlying content is free. Okay. So what we have here is just basically a simple proof that you can map from the cloud framework to the NIST framework. You could have got the first 3 columns from that Excel sheet I just showed you. Obviously, the Excel sheet just showed you the control code. Here, we've just added a full description of what the control title is. Okay.
Yes.
So nothing too remarkable there. We can extend that though, so that we can. Now we're going to make it a little bit more complicated. So now we're just going to map from the cloud framework, map into the NIST framework, and then we're going to ask the database to tell us what are the requirements required to realize that framework. And we're going to filter our search based on the fact that, filtering it is the next one. Filtering is the next one. So, okay, we've just made the search path a little bit longer, and we've mapped from the NIST control requirement, the NIST control objective, to the various requirements that you need to realize to make up that requirement. If we add a filter to that, we can see that now we're using those properties of the cloud of the cloud framework for saying, okay, imagine you're a situation where you've got a particular SaaS application in mind, a particular vendor. So now you only want the controls or the requirements that are relevant for an application provided through a SaaS vendor, where it's the provider's responsibility. And you want to check that they're fulfilling those requirements so that you can have some assurance that they're meeting the cloud matrix standard. Right? So we run that and say very simply from going through that graph, we have you can see here that the architectural building block always includes the application. The model always includes the SaaS. The responsible is always includes or is exclusively the service provider. And now we have the controls, the requirement code, and the requirement. Very simple way of knowing.
Perfect. Right. I think, as you said, this really made my eyes pop out.
Yeah. But this is it's kind of you show this. I show this to data modelers. They're not impressed at all because there's no nearest node neighbor. But it can get better. So do you remember that the cloud included the Institute of Professional Accountants model?
Yeah.
Suppose you were in a situation now where your organization wants to use this American SaaS provider. Your organization is internally using NIST as its baseline framework. It uses the Cloud Alliance framework to kind of like map external cloud applications into that framework. Yeah. But you want to use this American vendor, and the only certification they've got is the APA standard, right? You want to know what's the difference between what is certified under APA and what we need for our cloud matrix. So we can write a simple little query like this. This is the positive case. Show me the cloud controls that map to APA. right? You can see each of these controls have got a proper APA mapping. What's more important to our situation, though, are the controls that are not covered by APA.
Yeah.
So in this scenario, we keep those filters on application, SaaS, provider, but this time we say it does and does not exist in APA, right? These are the controls that they may be missing, they may not be missing, but they're not covered by the certification that they're offering. Okay.
Yeah.
So here again, you can see, looking at the 8-bar column, there's nothing there. So these are the things we want to go back to that vendor with and get further evidence of their compliance, so that we can say their compliance to the CSA, and therefore we can keep our NIST rating. All right.
Yeah.
So now what we want to know is, what questions do we go back to that vendor with to fill these holes where these nulls are missing? So here we go with the questions. Again, it's only a 6-line query, and one of those is a comment. Match the assessment questionnaire that influences the control objective, that maps to the control objective in NIST. Again, the filter application, SaaS provider, and not in APA. And we run that, and here we go. These are the questions you need to go back with. Now, some questions repeat on multiple lines because they cover more than one NIST control. To get that down to a single list of questions, we just edit out those last 3 columns. There you go. Those are the questions you go back to that vendor with.
Okay.
To get further evidence so that you can bring them up to the CSA standard.
Okay. Yeah, perfect. This is fantastic.
Yeah. So no, I mean, it's just such a simple technique to apply to your enterprise architecture models, but once you've done it, a whole world of possibilities open up to you. You're only really limited by your imagination.
Correct.
I think this is what I find exciting about this.
Yes.
I'll stop sharing now and bring you back on the screen. I can see you.
Absolutely. So I think you open the whole thing to how graph database can really help make decisions quicker, make everything transparent in a quagmire of information, actually.
Well, I compare it sometimes to, you have like continuous integration, continuous deployment in your software.
Yeah.
This is leading to the same thing for architecture. So you're doing it with your designs before you push things into production.
Yeah.
You can run a suite of scripts on your architectural models every evening if you want to, and just check that everything is in shape from a compliance point of view, from a risk point of view, from a criticality point of view, from a personal data point of view. Really, and if there's something missing because there's not enough information in the model, then please tell me.
Yeah. Sorry, Stephen. We might get cut in like 2 or 3 minutes, I think. But I think
we're just about done.
Yeah. I think we are almost near there. And I think fantastic for summarizing the takeaway from this. That's really huge because you can run through
a lot of material to cover.
Absolutely. But this is really good. I think I'll split it into 2 parts and upload it for sure, so that people have the liberty of watching it one after the other separately. But I think the takeaway is really great that how you can speed up architecture decisions. But otherwise, the enterprise architecture decisions are spread out. The old world, they were across multiple places and in various PowerPoint presentations, in Word docs, Excels, and all. So you can't make sense of it holistically here. If done well, then it's all at your fingertips.
Well done.
Easy.
Okay, well, you've got it, and thank you for staying with it, because it's a lot to take in. I do realize that.
Okay, but it was I wasn't expecting the last part of it. That was a big value add. So the way you showed up how it really pans out in the real world is actually really nice.
Okay,
that's the tipping on the icing on the cake kind of stuff. So that's really a huge value. Thanks,
So,
Steven, for your time. Yeah, please go ahead.
yeah, one more thing. Some of these things I hope to be presenting at COSAC in September. Some of these things are still work in progress, but there'll be some announcements over the summer and some demonstrations at COSAC.
Yeah.
So yeah, if anyone would like to see
sure,
that,
I'll leave your coordinates at the end of this video, and they would be in touch with you. And also, you said you perhaps might be working with the government on furthering this research, right?
Yeah, we're very lucky. We've got some research funding from the Belgian government to actually the Flemish government to fix and develop this technique. Right. I mean, most of what's done here has been done in spare time, out and applied in work projects, but
it has a lot of ramifications on other enterprise tools also, like Sparks, or I think you could pretty much use this in a lot of places.
Exactly. It's not. I mean, okay, I've used some of the special features in Archi, but another reason for going to the graph database is because I didn't want this overlay to be tied to any particular vendor. So by converting it into GraphQL rather than a specific Archi tool, then it makes it accessible to all.
Okay.
Yeah.
Thanks, Steven. Thank you for your time.
All right. Keep in touch. Let me know.
Sure. I'll be in touch. I will ping you once I've uploaded the recording. So have a good weekend. So the weekend is already over, looks like.
Yeah, enjoy. Thank you very much again. Bye.
Thanks.